Right, in this video we're going to look to find the gradient function of a reciprocal function and a cube root function. So it says find the value of the gradient of each of the following x is equal to minus 8. So y is equal to 2 over x first of all. So we've got y is equal to 2 over x. Note that 1 over a to the n is a to the minus n. So you need to rewrite this first before you can actually carry out the process of differentiation in order to find the gradient function. So rewrite, you're going to get that y is equal to 2, and then the x comes up and we write that as x to the minus 1. Now you can apply when y is equal to kx to the n, differentiating or finding the gradient function dy by dx is bring the power down in front, write down kx and reduce the power by 1. So applying that to this means we bring down minus 1, write down the base again, so it's times 2x, and then reduce the power by 1, so minus 1 take away 1. So that's going to give me minus 2x, and then the new power will be minus 1, which is minus 2. So rewriting that using this, that becomes minus 2 over x squared. So you do need to know your rules of indices. Right, when x is equal to minus 8, so x is equal to minus 8, we put that in here. So this is our gradient function. We're going to have that dy by dx is minus 2 over minus 8 squared. And therefore dy by dx will be minus 2. Minus 8 squared is plus 64, but we still have that minus sign at the front. And minus 2 over 64 gives me minus 1 over 32. So if you look at the graph of y is equal to 2 over x, x is equal to minus 8. The gradient of the curve at that point is given by that blue tangent line there, and that gradient of that line is minus 1 over 32. Right, for part B, which says find the gradient function of x is equal to minus 8 for the cube root of x. So we've got y is equal to the cube root of x. So note that the nth root of x is x to the 1 over n. So you need to know your rules of indices. So you need to rewrite this as y is equal to x to the 1/3, and then apply when y is equal to kx to the n, dy by dx is n kx to the n minus 1. So that means the gradient function, differentiating now, you put down 1/3, write down the x, and then reduce the power by 1. So that becomes 1/3 of x to the minus 2 over 3. Right, so now applying this rule in reverse and the previous one, so I and this one, a to the m over n is equal to n root of a to the m. The minus sign means this is 1 over 3 x to the cube root of x from the 3, and then raise it to the power of 2. So you need to be able to use your rules of indices. So when x is equal to minus 8, now substitute that in, you're going to get y is equal to the cube root of minus 8 squared. Now if you square it and then cube it, it doesn't matter which way around you do it, but it's easier to take the cube root first. The cube root of minus 8 is minus 2. Alright, so you get 1 times 3 times minus 2 squared. And minus 2 squared is 4, so 1 times 3 times 4, that becomes 1/12. So again, if we look at the graph, this is the graph of y is equal to the cube root of x. So here is the point where x is equal to minus 8. This is the tangent, and the gradient of that tangent will be 1/12. You're not really expected to draw these graphs in an exam though. The gradient of the tangent at x is equal to minus 8 is 1/12. So this has been a video to show you how to find the gradient functions for a reciprocal function and a cube root function, and then finding the gradient at a particular point. I hope you've understood, and I thank you very much for watching.